Okay, I think we're going to get started. Can you give me a thumbs up if you hear me okay? Cool. Okay. So this presentation is about creating the PreProd environment, and it also covers a little bit of material about what an environment is versus what an internal deployment is, and it goes into a little bit of why we need this environment to begin with. So I'm starting off with this summary. What is pre-production? Just to kind of give you a general overview. We needed to build this environment because this year we're planning on trying to improve GitLab deployments in general. And these are deployments that go to gitlab.com. We are planning to make them more frequent and to make them more reliable. And in order to do this, we discovered that we really need a new environment other than staging, just because there's so much contention for staging when we're validating fixes. So initially, this new environment or this new deployment of GitLab is going to be used for testing fixes that are made after we deploy to production, perhaps security fixes, maybe fixes for regressions. But it kind of remains to be seen exactly how we are going to use it. But in a way, this is just going to be something that runs alongside of staging that we can use for validation before we go to production with code. There are a few differences from both staging and production. Initially, this is just going to have a fresh database. It doesn't have any customer data on it. It's completely separate from production, doesn't share any infrastructure. This means it's in its own GCP project. We're managing access with Google OAuth. And also initially for this first iteration, it doesn't have any HA, but we are building it with HA in mind to be added later. To start off, I'm going to kind of go through the different environments and starting off with just internal deployments. And I wanted to kind of begin this slide with just talking about single installations, because these are quite easy. And it's one of the things I really like about GitLab is that we make it extremely easy to install on a single server, and that's thanks to the Omnibus package. Despite the high number of moving parts and the complexity, all you need to do is an apt-get install or an RPM install, and you can have a running GitLab instance. This, of course, has some shortcomings. One is that it's a single instance, so it doesn't have any high availability. Of course, there's other things like the logs are on the instance itself, so you need SSH access. There is monitoring, but it's through the GitLab application, and it doesn't monitor everything that you might need to monitor. All of the assets are locally on disk, so if you want to use object storage, there's some additional configuration that you'll need for that. So this is where we introduce environments, and the first tier of environments introduce these sort of additions, and these are services provided by the infrastructure team. You have Chef managed servers, you have centralized logging and monitoring, runners are connected that are managed by the infrastructure team, object storage, and central authentication. I put these two as the first examples because they're the simplest, dev and ops, which I'm sure everyone has used or most people have used. Dev we use as the nightly CE build of GitLab, and it's installed to every day, and it's also used for some of the release process. And ops is where we store all of our operational tooling, and it's where we initiate a lot of our operational tasks for using runners that are connected to the ops instance. The next tier is I'm putting this new environment, PreProd, pre.gitlab.com. It introduces a bit more. It has a bastion, it has some HA, and you can also do chat ops deployments. And then the last tier of environments are production and staging. Of course, production and staging are extremely similar in topology, although they do have some differences, like the number of instances is much smaller for staging. In some cases, the instance sizes are different, but we typically keep them the same. They have separate databases. Staging, of course, has production data in it so that we can test against it before we go to production. And production has this DR environment attached to it, which is a geo deployment, which is currently being built out. And both of them have Canary. I'm not going to go into more detail here on what the Canary deployment is or what the Canary stage or the geo deployment, but this is sort of the layout of environments that we have internal to GitLab. So let's just kind of summarize, like, what is an environment? And these are all services that the infrastructure team provides. You have Chef and Terraform, centralized logging, monitoring, and alerting, authentication, access with a bastion. We have to set up network peering to the operations, the operations infrastructure so that we can do deployments, Rails and DB console access for developers that we control. And was someone asking a question? No, okay. And also, like, we can configure these environments with a very similar topology to GitLab.com that includes like Patroni, multiple Redis clusters, CDN, and traffic segmentation.
Shane, I think you're unmuted, just FYI.
Okay. I'm going to talk here about the very minimal viable product for PreProd, and this was purposely done to make so that we can create this thing quickly and deploy to it as soon as possible. So it's very simple, or as simple as it gets when it comes to environments. We have a GitLab server, we have a runner, we have a bastion, we have monitoring infrastructure, which includes Prometheus and the alert manager and some exporters. What this doesn't include are some of the things that we may or may not add later, and we probably will, but those are in the gray boxes, like load balancing, having a dedicated HA Patroni database and Redis clusters and separate Gitly servers. And I guess the thing to keep in mind here is that we've built out kind of the basic environment here, and we can add to this later as we need it. Of course, it needs to be peered with the operation infrastructure, which is on the right-hand side. This gives us centralized logging as well as monitoring and a whole bunch of other goodies. And that's pretty much it. So I'm going to kind of talk about what we need to do to create this very simple environment. And it's going to be broken down into a few bullets. We're going to start off with Terraform. It's about 600 lines of Terraform config. That sounds like a lot, but it actually isn't that much because we use shared modules. And this is just a copy and paste from other environments. There are some things that are unique to the environment, obviously, like instance sizes, counts, subnet allocation, and then which fleets we're deploying to. But more or less, it's just a subset of staging or a subset of production. Another thing is that we have to do some chef configuration, and this usually involves creating new chef roles for the OS level configuration that is specific to that environment. This includes things like endpoints. It includes any kind of labels and things that we need for Prometheus. I kind of just broke these down into monitoring infrastructure, Bastion, the GitLab application, which fills out the GitLab RB file. And then I just put a note here that we don't use Chef for the runner because it's deployed in GKE, which makes it a bit easier. Other things we need to do is that we need to create a new ChatOps command for deploying to it. This could be a little bit more generic, but right now we have separate, a separate option for each environment. So we needed to do that. We needed to create a deployment pipeline, and this involves just editing the GitLab CI.yaml for the deployer. I'm not going to go into too much detail there, but basically you create the changes, or you make the changes to the GitLab CI.yaml, and that allows us to have these stages for deploying to the environment. And then you have some other things like documentation and monitoring. Of course, we need runbooks, we need a dashboard, which is a manual thing for right now, and where to find logs and things like that. So what I did here is that I broke this down into days to kind of give you an idea of how long it took and what needed to be done day by day. It took 6 days to do. And I think, my manager asked me like what year it is. And I said, oh, it's 2019, because he thought it was like 2015 or 2005 or something like, but it doesn't matter which year it is, because it's just ridiculous that in 2019, it takes so long to build this environment. And I'm going to try to explain here why it took this long. And then at the very end, I'm going to kind of go through the improvements that I think we could make in the short to medium term to make this a little bit easier for the next person. Day one, of course, you create the project in GCP. You have to enable all of your APIs and quotas. This is all very manual, and it's not easy to automate. And then you create your initial MRs for the Terraform config. This just creates like all of the base infrastructure. Day two, I created all the chef roles, and then the first big milestone is like, provisioning one server in Terraform, ensuring that it can boot and register properly with chef. There was an issue here that we had to work through because there was a problem with TD agent, so that took a little bit of time to debug. Then day three, this is like where now you have most of the infrastructure up. Ensure that the GitLab application is configured. You want to make sure you can log in, and then you have finally like a full run of Terraform without any, without any errors. Everything is up and running, and so now you're just down to kind of like the last configuration. On day four, I decided just to destroy everything and reprovision it, because I wanted to make sure that it could come up from scratch. And then there's some manual things, like I had to create OAuth credentials for logging into pre.gitlab.com. So basically the OAuth credentials that allows anyone with a GitLab.com email address to log in, and for the Prometheus servers as well, since we have OAuth enabled there. Day five, ensure that the runners are configured and connected to the GitLab instance. This is pretty easy because it's all in GKE. I committed a runbook that shows you how to do this. Basically follows our instructions, but makes it even a little bit easier for our specific use case. So I do this a lot, and it's very simple just to like create a new runner cluster on GKE. We have to configure the peering between the ops environment and the PreProd, which we talked about earlier. Of course, like I realized after this that there was some overlapping subnets. I had to resolve that. We have to generate SSL certificates because we're connecting to pre.gitlab.com. We don't of course have a wildcard certificate, so we have to generate a certificate, update it in secrets, reconfigure. The registry also needs its own SSL cert. And then you just need to go through everything and confirm that all the configuration is proper. So, like we have a lot of files that are stored in object storage, and they each have different buckets. So you have to make sure that they're all working properly. Day six. So this is like granting access so that anyone can log in. Creating the deployer pipeline, create a ChatOps command, create a new Slack channel for that ChatOps command, create a dashboard for the PreProd environment just to kind of have some kind of overview, and then test the deployment. And this involves using GitLab ChatOps. You can see the command there. We run the deployment. It creates this nice little CI pipeline. And then if everything works, everything is green, and then you can move on. And then on the seventh day, I guess like, you can rest, or you can kind of think about how you can make this whole process better, or maybe question your life choices, because it is like a lot of work to get it working. I did include a detailed log of everything I did, including all of the issues I ran up against for the next person. It's way more detailed than most people probably are interested in, but for maybe the SREs, if you want to see, feel free to access it at that link. So I came up with a list of things like, these are the things I would like to automate to make it completely self-serve. And it's quite a list. I mean, there's a lot of things here. And I think we can maybe kind of rethink of how we do these environments in general to make this list shorter. But there are a few things that I think I would address right away. And I put this here. So the top three things, I think, like in GCP, having a GCP project that is dedicated to an environment is not always the right choice. I mean, GCP comes with a lot of overhead for creating projects. Like it requires you to enable APIs, it requires you to adjust quotas. They can't be disposable. So we probably would just want one project for like all all of our environments if we were going to create lots of them. Second bullet, using Chef to maintain host inventory just doesn't scale. And I think most of the SREs realize this, and it's something that we've been talking about a lot. If we switch to using a central console cluster for like managing our host inventory, then and some reasonable or like pretty strict conventions on how we name things, then I think a lot of the configuration where you just like either have to have raw IP addresses because we don't have internal name resolution across projects, or you know, like anywhere where we have to like use host names, it's just going to be easier if we can have DNS lookups on console. Having a more consistent bootstrap definitely would help. We do a lot when we bring up a new server. It includes, you know, we start from the base OS, so there's a lot of opportunity for things to go wrong during provisioning. Using images would just be a massive improvement, and this is something that is currently being looked at in that epic. Came up with some other improvements. These are like lower priority things, but you know, we do manual private subnet allocation because we have to ensure that subnets don't overlap for peering. This is something that we could probably manage a bit better. For logging, like everything that is not you know, staging or production is sharing the staging indices. So for Elasticsearch, so that maybe we could come up with something better there. Chat ops and deploy could be a bit more automated and generic. And then for database, I would say like, you know, maybe if we had a lot of environments and we were bringing up a lot of them, having a shared database cluster, Redis clusters with multiple databases, because I think HA configuration, I really just don't see us automating setting up a Patroni cluster and tearing it down quickly. It's just something that's a little too high touch. So I would say like having like infrastructure that we can share across multiple environments would make that a lot easier. That's all I have. I'll look at the chat to see if there are questions.
Just the one. It was just I was wondering, since registry requires that extra bit of configuration, if it was going to be included, but if it's a copy of the other environments, there's probably roles for it.
Yeah, so currently for PreProd for registry, it's running on the instance locally, just like it does on dev and ops, which means your registry images will go to object storage, but the registry service itself is on the same instance that the Rails app is running. And to connect to registry for PreProd, you just you use registry.pre.gitlab.com. For pages, it's actually not enabled for PreProd, but it's something that we can add. I don't have like a separate fleet for the pages service. The service itself is running, but it's not configured so you can use it yet. But that's something that we could possibly add.
Thanks.
Are there any other questions?
Hi, John. It's Mel from Compliance. I had a question. I think it was maybe about slide 4. It looked like there would be some potential connections between these PreProd instances and ops.net or logs.gitlab.net. Is that those quote production instances of those sites or those environments? Yes, perfect. That's the slide.
Yeah. Yes. Yeah. So we allow connections for and it's fairly selective. We have specific subnets. So the way it works is that you first create a peering, and then you use firewall rules to restrict like which subnets can access which like boxes on either side. So we allow incoming connections from the ops infrastructure for monitoring, because dashboards.gitlab.net needs to use the Prometheus server on the left as a data source. So we allow that on the Prometheus subnet, we allow connections from dashboards.gitlab.net. For the release runner, we have to, and for operations like maintenance, we have to SSH from the release runner. So we allow the release runner to have pretty much all access to all of the internal IPs on like all the subnets, but it's limited to the release runner. But maybe if I'm not sure if I'm answering your question, but
no, you are. I think that
okay.
my initial concern was generally when you have these types of pre-production environments, seeing those connections with production infrastructure, there's potentially some issues. If you're saying that based on firewall rules, that's certainly some kind of controls that we could potentially, and Jeff, let me know if I'm capturing this correctly. We could validate to make sure that there is no bleed or leakage.
Yeah, I think
the direction of those connections.
Yeah, exactly. I think that would be a good thing to scan for. Like, for example, on the left here, pre-prod can't talk to production, but ops can talk to both pre-prod and production.
Exactly.
Yeah.
Okay, perfect. I just wanted to make sure that I was seeing that correctly, and then that's just a kind of a to-do for you and for your group and the compliance team to actually fully vet that out so that we have a full understanding so that we can either suggest additional controls or say, nope, this is the way it is, and then speak to it in the terms of an audit. So thanks.
Yep, cool.
I appreciate it.
No problem. Any other questions? Okay, well, thank you, everyone. If you think of anything else later, always feel free to hit me up on Slack. And thanks, everyone, for attending. Bye.
Thanks, Jarvis.
Thanks, Jarvis.